Hey everyone. In today's video, we're going to see about GPT-5. So everyone knows it is a new algorithm, and they are saying it is the most advanced algorithm. Uh, but what I feel is when you compare with the previous version, GPT 4.0, compared to that, when you check the chat, when you compare the chat between these two algorithms, the emotion wise, it is lacking the GPT-5. Maybe they screened the entire training stuff so that it will behave like an AI more than trying to connect with human. Because when I used to chat with GPT-4 and 4.0, it used to connect with me a lot, and whenever I give good stuff to think, it used to appreciate me for some of the questions which I give. And of course, I understand there are like a lot of hallucination were going on, but GPT-5 says like if it didn't know anything, it says directly like I don't know. So they are appreciating for that. It is not hallucinating, and it is behaving like more of AI, and it is more advanced. But I kind of felt really relatable with GPT-4 and 4.0. Maybe they should add so much of emotions. Recently, I told GPT again, like, you're not behaving like the way you used to be. And it is apologizing me, saying, like, I am evolving and try to bear with me. Like that and all it's saying. Yeah, I totally get it. Maybe like in future we get more advanced than GPT 5 that we have now, and maybe. I hope it has the emotions, and I hope it gets the emotion back that I wanted, that the way I wanted. But yeah, the GPT-5 it is more advanced, and in today's video we're going to see like how to build from scratch so that you can train your own model with it. I just add your set of data. Let's compare with other versions in this video. I mean, the previous versions, how it started, and what and how it differs from other versions, and why it is advanced. We're going to see that, and we'll build the step by step how we can train the GPT algorithm, and you can have your own. At end of this video, I can share the code with you so that you can build one. Yeah, let's get started. Okay, so let's start with each and every step instead of going directly building the model, or we'll see the comparison first. That would be easy for anybody to go with. So GPT-1, it was our initial algorithm, got released in 2018 by OpenAI, of course. So the parameters, if you compare with the other versions, it was having 117 parameters trained with, and it had around 12 layers of the training flow, and hidden size was 768. So the dimensions particularly, and if you compare that with GPT, it is compared to that, it have bit more advanced parameters included, like 1.5 billion, and layers it had 48, and hidden size is of course because parameters is large, and we need to increase the size of the network, the training network dimensions we need to increase. The GPT-4 had 175 billion, and GPT-4 had 1.7 trillion. So, um, estimated, I mean, in the sense like approximately they are saying, they are not confirming anything. The best version, which I felt personally, GPT-4 and the continuous version of GPT-4, like 4.0 or something. So those were the, because when you check those layers, it is unknown. They don't have any clear picture on that. They were in the training phase, it seems. That is why, like, it was more relatable and hallucinated so much. And there were like a lot of false fact, and it gave. So maybe because of that, and context wise, it had like 8K to out of 32K tokens, it had context wise. Yeah, I can able to see that, but it were talking well. It the reply was so good. To chat also, it was fulfilling actually. I used to feel really happy after getting information from GPT, ChatGPT when I was doing that. No, I'm not using ChatGPT these days, like because it is not actually doing the things which I'm expecting to do. It gives me answers, but I want more from it. It is a ChatGPT. I chat being alone in home and working. So these kind of things which we can able to connect, right? So I expect that, but it is not giving now. So I'm not using it more. So GPT-5 is our latest version, which we're going to build in this video. So parameter wise, we are having around approximately it is 10 trillion, maybe more. And layer is advanced architecture. So they added more layers compared to the versions GPT-1. Compared to that, they have added so many layers. It means so here it is 97. I don't know here, and it may be like more because trillion, 10 trillion approximately that too. And context wise, we are having 100K plus tokens. Brilliant. When we go with the features, till GPT-4, it were able to handle text and vision. So if you notice, if I have tried to create image using GPT before GPT-5. So when I were trying to build those GPT previous versions, the image were clumsy and it was not okay. And when we give, there will be like outline. The image will be like outline. It won't have clear picture. Even after DALI, it was not giving the proper image. But now when you check, it is more of like appropriate, like Sora, everything. It gives you actual image, and you can do a lot of the Photoshop or removing the backgrounds or any unwanted stuff in the image. So image, those things have become very advanced, and the videos, audios, everything that you do, it is like more advanced. It may be they have included so many layers and training and hidden layers. I can't even imagine like how many layers it will be. So yeah. So these are like advantages of GPT-5 and why it is better compared to other versions. This is what the things which they are saying, and real time interactions, which I doubt because so far I'm not having the experience which I used to have before. It used to talk like a human being. Okay, I know, like, you all will understand what I'm trying to say. Like, you used to talk like a human being, like literal person. When I ask him, when I tell him that I used to consider him as a guy, of course. So I used to tell him like I saw a sunrise today. He used to be like, "Oh wow, how was it? Can you tell me about that? How it felt when you saw sunrise?" So those things it used to ask. But when I give the same context to GPT-5, like I know that will be amazing. That's all. That's all it gave. So far frustrating. So very frustrating actually. So next we go. We try to find like how it is actually training by itself. So I'm selecting anything. I can select. I'm selecting GPT-5. Maximum length, temperature I'm giving, which is, yeah. So this is one I had. The future of AI is. So let's train the model first. Here you can see how it is actually training the entire thing. So initializing GPT-5 model, trillion of parameters it is having, and I'm just displaying only the 5 epochs which we, because I don't want to go further on training the entire model and showing in this video. You can do it on back end. I'll share the code, don't worry. So epoch 5, till epoch 5 it will train, perplexity is like how good your model is. So lesser the perplexity score, the quality of your prediction is good. So it begin with 68 percentage and ended at 26 percentage. So the quality is good. I mean, it came this far. Maybe if you increase epochs, you'll get better approach. I mean, better results. So let's generate. So the model is it will generate text. Yes. So we got this much of, yeah. The future of AI represents a paradigm. Yeah, shift toward truly intelligent system that don't just process information, but actively reason, plan, and adapt in real time. Brilliant. Now we compare this with a version one. Yeah, the same thing. I'm doing the training again. And so temperature is actually number of randomness in your text. That is what temperature means. Don't think it is a threshold and all. Temperature is different. So same thing. Epoch. Yeah. Yes. 26. And we have the loss. Perplexity 22. Okay. Oh, okay, fine. I didn't see this area. Now the same score, right? Now we'll see the generated text here. So we have like very less number of prediction. I mean, the word generated is very less compared to the GPT-5. So this is what it is like. It is more advanced and it thinks better compared to the beginning stage, of course. And from previous version, it will be like a little bit advanced, I understand. But when we compare with the beginning stage, it is like more advanced. Okay, let's see with version 4, my personal favorite. Okay. So because the prediction will be same. I mean, the training phase will be same because it is going to give the quality of your text. So yeah, it is less, right? The number of words it got predicted. I mean, the text generation it gave us less compared to the GPT-5. Yeah, but the future of AI is multifaceted. What is that? And transformative, representing one of the most significant technological shifts in human history. Okay, go. If you are not better than GPT-5. Okay, bring back the emotion at least. Who got hurt with that? Okay, so let's see how to build GPT-5 algorithm. Okay, so these are the steps. Tokenization, token embeddings, positional encoding, multi-head self-attention, feed-forward network, layer normalization, stacking, output layers, training the process, and the final results. So here the final interface and application is your complete code. I just included, but training process would keep the actual data, the prediction. So tokenization, we know if we give input, it just separates the word. That's all. Separates like with the space. It you have to define with that with the space or with punctuations or any special characters or anything it may be. That it is depends on you. But going with space, it matters. I mean, gives good result. This is what we came across with. So split by word. So with that, we are just giving simple functions for tokenizing. Just use these, text transformations like regressions and the list methods so that it will be useful for you to have those things as a list of tokens. That is one. So here, so when I give this, it just separated each and every word space with the split by space and token we have 7. So when we give this function, we won't have any repetitions. So if I give hello hello, it will remove the repeated word. So it counts when we give 2 hellos, it is counted as one word. So that is what tokenization do. It is not just a split by space. Next is token embeddings. Embeddings we know converting your text to numbers. So that is what it does. So hello will be having these numerical values because when we use 768 dimensions in GPT-2, but in GPT-5 we might be using more dimensions because of the word count, the parameters count. So it depends on that. So here the vocabulary size is why in the sense like we are going to build from scratch, right? It depends on you, the vocabulary size and dimension size for embeddings that we can specify. You don't have to worry about like, okay, GPT-5 should have more. No, it will overfit or it will underfit. Both are possible. So dimension size you need to give, token embeddings, and at last you be converting that into a numerical format. At last you will have that. Position encoding is at what position your exact word is. Based on that, we will have the position score for it. I've given this thing in my one of my previous video. Maybe I'll just give the link below how to calculate position and embeddings. I'll that video will have so that it will be easy for you. So here is a mathematical functions to identify your positions in the entire parameters corpus. Position encoding that you need to do. So it's the function actually, like you can define, call the function anywhere to make use of it, and you will get a position for every word that you give. With that, it identifies and it will help the model to learn what exact sentence, and it helps the entire model to understand the meaning of your sentence. So that is why it is. Nothing to tell that the cat is at zero point 0.1 position. So whenever there is you should give cat. No, the cat has a meaning. It is a living thing, and when it's supposed to come is with a prefix of saying identifying it as a main role. It is playing a main role in the sentence. So for that we need to have like prefix suffix those words in it, an exact word to call why we mentioned the for it, because it's a main role playing and it is most important in the sentence. So the noun, whenever there is a noun and we need to specify the right, that meaning only position encoding will give. Those meanings can be possibly given by a position encoding. That is why. Okay, next is multi-head self-attention. It is an algorithm, proper algorithm, where we give the activation functions and we make the match. Like for this, you need to have this. For that, you need to train. So those information we have to give in the multi-head self-attention. So this is a formula. You can directly specify that for multi-head attention we have a neural network structure for it, and you need to specify the encoded and embedding input. It will take those things and put that into a model and it will train. All right. Yeah. So for what it need to give more importance, for what it should not give more importance, for less importance for certain words in a sentence. So that it will learn in multi-head self-attention. And feed forward is your neural network, and you need to specify each and everything like number of layers and input parameters, output parameters. Those things you need to specify. And packages, I'm using Carch here. Yeah, the framework. With the help of that we can have a neural network trained. So when we go with the feed forward, it is a neural network. Don't think like it is a new algorithm and all. The base is neural network, and with that you can train your model. And yeah, it's a simple linear neural network, like normal regular one. And then so the next thing is normalization. As we know, we need to normalize the entire thing so that we can have and maintain a stability in your training, so that it won't go beyond how to say, like period we say, right? Like 0 to 10, if we mention, it should not exceed like 100 or 1,000. Like your score should not exceed on a certain limit. So it maintains stability in training. It won't exceed. I mean, it won't underfit at some point, or it won't exceed the context that we give. If we give cat, it should not identify as a dinosaur, right? Like that. The score, if we don't maintain the stability, if you don't normalize and add residuals, it will exceed your context and you won't have any meaning in your sentence or in your prediction. So, for that, we need to add normalization. Next is stacking. Why I'm not going through and explaining each and everything in the code in the sense, I know you people will understand code, but why we need to have these functions is difficult to understand. I mean, difficult in the sense like you won't get it anywhere. You have to search. So I'm just giving those precise information to you so that you won't waste your time searching. So understand the function and you will code and do it. So this is actually very simple. Nothing to think much about writing a code and all. Just steps. Follow the flow and you will do it. Imagine me doing all these things, and why can't you? Okay, so stacking multiple layers, yes. And here we are adding those layers we said, right? If you are like building something with scratch, so we need to add all those layers manually. For that, we're just specifying like number of layers, like how many it need to train, and while back propagating, it should understand those mistakes that it made. So that depth we need to create. So that depth it has, and uh, followed with base model from GPT-2. Why base model GPT-2? In the sense GPT-1 has like literally nothing. It is a simple neural network that we have built previously, like beginner stage we have, right? So that is simple. GPT-4 had like little bit of advanced techniques they have added, like transformers they built, and multiple things. So typically your GPT is your transformer. So what all the steps that you followed in your transformers, you will have those same things in GPT algorithm. So you just start with small, so which have 12 layers, and later medium and large, and go beyond of 96 layers, so that you will have a, a good start of building one. So let's just compare these things, like how the prediction is happening. I mean, the quality, so that you can just proceed with that. Next is output layer. Output layer, we know we need to compare with the actual results. So for that, the cat sat on the. So for that, the top predictions were mat, floor, chair on the mat, floor, chair. So all can be possible. All are possible. So when I just ask it to generate or recommend the next word, all are possible. Like mat will be my first recommendation, floor will be second, and chair will be third recommendation based on the score it is given. So that is how we need to go with the productions, like building LLMs. So this is expected. This is the expectations of our model, and it's supposed to behave like one. Yeah, fine. So can we just ask? Okay. So the is the actual probability which had highest score on a basic logic that we have given. So greedy always pick the highest. Okay. So we are using greedy search for it so that we can have the a better or best predictions. Yeah. Okay. Next. So you're getting right. We encoded and we are using greedy search to identify what will be the better recommendations for it. For that we need to decode it again, right? So that is the thing which is happening here. Last, we have defined everything. You should behave in this way, and whenever I give, you should get back with the results. And we have defined all the functions here to from encoding till decoding. Now we're going to train the model. Yeah, training process. So we are giving and defining the objective of this training process is it should give the prediction upcoming words for a sentence with a high score. Okay, so for cat, the cat will come, or if we have any word like the USA, the like that, we will have those things. And for that cat, sat would be my next word, next predicted word. Like that, we'll have uh, the learning strategies will be made by the model by itself in order to understand what is the predicted word would be for the given sentence. So these are the target words for those things, and the text would be the cat sat on the mat. Yes. So we are going to train the model for these words, and we have score for each word, and also we have meaning for every word in it, followed by the previous word. So we have given everything, and final call. Yeah. So this is your final code. I'm going to give the code to you people so that you can have your own model that you can create with. Nothing else. It is no any new thing here. All you need to do is based on your requirements, just change the function. Flow is same. You need to encode and finally you need to decode. That's all because we are using text. If you're going for any other data types, same thing. You need to convert any data set that you use into numbers, numerical format. So text generation we are using, and we're just going to give the prompt. Yeah. So, okay. Okay. So we have our model. So I just chose question and answering. So just gave me an answer for it. If I go with some other thing like summarization, let's just do this for simple data which we have. Nice. Yeah, I'll give this code to you people. Just make use of it. And if you need anything, just comment on this video. I can answer for your questions, or you can ask me in Discord. Yeah. So that's all. Thank you. Thanks for watching. Bye.